Hey guys, so we're going to go ahead and do our first lesson in our first unit, and it's lesson 1, which is function basics. And so first it's a little vocabulary, and it's where we're talking about a relation versus a function. So what is a relation? A relation is very generic. It's just any set of ordered pairs. No rules to it. It's just any set of ordered pairs. So a relation is going to be a set of ordered pairs. But then we have special relations, okay? So we have special sets of ordered pairs, and one of those is a function. And so a function is a special relation between two variables such that to each value of the independent variable called the domain, there corresponds exactly one value of the dependent variable commonly known as the range. So what is that saying? So what it's saying there is that a function, your x cannot be repeated. So a relation is any set of ordered pairs, no rules. But a function is a special type of relation. It has a rule. It says x cannot be repeated. Excuse me. Now it doesn't mention anything about y because y doesn't matter when we're just looking at a function, okay? Only the x cannot be repeated. So let's look through this first example here. So it says determine whether each relation represents a function and justify. So look at A. A has this set of ordered pairs, but notice the first one and the last one both have the same x value that is 2. So this is not a function, this is a relation only. And that's because the 2 is repeated. The x value of 2 is repeated. Alright, what about B? The area of a circle is a function of the radius. So your area formula was A of r is equal to pi r squared. So just think about this. If I said, just do a little example over here. If I said, okay, well, let's let r be 1. We will have A is equal to pi times 1 squared, which is just pi times 1, which is just pi. So we end up with the ordered pair, our input of 1 and our output of pi. Okay? If I ever put in a 1, will I get a different y value? No. We only get pi. Every time we put 1 into that equation, we're always going to get pi. Therefore, it is a function. And that's because the area depends on what the radius is. C is still a set, okay? It's not numbers, but it's still a set here. So we've got these ordered pairs. So our first is our x's, our second one is our y's. And so look, are any of the x's repeated? No, none of them are repeated. So therefore, this is a function. And so no x value is repeated. And that should make sense. I mean, Andy can't have 2 birthdays, right? Andy can only be born on one day. So therefore, it can't be repeated. And then D. D is what we call mapping, okay? And so we map from the first oval to the second one. So if you look at here, what this is saying, if you notice, it goes from -2 to -1. So it's saying this is an ordered pair. 1 to 4. 3 to -3, and 4 to 2. And so if you look at them, you can tell the x is not repeated, therefore this is a function. Now, a quick way when it's in mapping that you can look at, let me erase what I've got there real quick. A quick way is just look at the x oval. You'll notice here that none of these, I should have included the number there. None of these, well, here we go. None of those numbers have 2 lines coming out of them. If they had two lines coming out of them, that would mean that that x value was being repeated. All right, so let's look at function notation. So we can see here that we have f of x. We've all seen this. The letter here, the f, is just used to name the function, okay? And some popular ones are f, g, and h, but we can have all different ones, okay? We can have f of x, g of x, h of x, k of x, z of x, any of x that you want, okay? Any letter can be used. But remember, f of x is the same thing as y, because if we have f of x equals 2x plus 4, that's the same thing as saying y is equal to 2x plus 4. And because of that, if we have that f of 2 is equal to 9, well, remember, we normally see this as f of x, and we just said above there that f of x is the same thing as y. So knowing that, my x would be 2, my y would be 9, which means I have the ordered pair 2, 9. And then there are 4 different ways to represent a function. We can represent it graphically by plotting the points, numerically by a table or a set of ordered pairs, algebraically by an equation in 2 variables, or in words by describing how the input variable is related to the output variable. All right, so evaluating functions here. This is given the function that f of x equals 2x squared minus 3x. Let's evaluate all of these. And so I am going to kind of run through these, and if you need to, pause the video, back up. I know I've been going kind of fast. You can do that at any point if you need to, okay? Pause it, back it up, whatever you need to do. All right, so notice for A, we're looking for f of 2. Well, they gave us f of x equals, and instead of the x, we now have a 2 there. So that means everywhere over here, we're going to replace that with whatever's there where the x was. So for this one, we're going to take the 2x squared minus 3x. And we just said we're going to plug in 2 where all the x's are. And then we're just going to work this out. So if you have your calculator, you can just throw it in there. If not, work it out. And we got 2, which means that f of 2 is equal to 2, and it also tells us, remember this is x and this is y, therefore we have the ordered pair 2, 2 on our graph if we graphed it. So look at B. B says we're looking for f of x plus f of 2. Well, let's check. Do we know f of x? Yeah, that's what was given to us, right, in the problem? Do we know f of 2? Well, yeah, we just found that in A. So we can add those together. So we know f of x is 2x squared minus 3x. It says plus, and we know f of 2 is equal to 2. So what I did is I separated them so you can see this is our f of x plus, and this was our f of 2. Now we don't need these parentheses, so I need to distribute anything that's in front of them to get rid of it. And so, didn't really change. Now we're going to combine any like terms if possible, which there are not. So there is our solution. Don't try to factor, guys. We're not there yet. So look at C. C looks a lot like A, except instead of just a 2, it's got a 2x. So we're going to do the same thing. Everywhere that there's an x, we're going to plug in a 2x. So we're going to work this out using PEMDAS. Be careful though, because a square is there. Square means what? That it's multiplied by itself. So I'm just writing it out. Now we've got 3 things here being multiplied. These are small enough you could probably multiply all 3. But I'm going to go ahead and just pick 2. So I'm going to pick the bigger 2. So I'm going to bring this one down. And 2x times 2x is 4x squared. And then I got minus, I'm going to go ahead and multiply that. And so I got minus 6x. Then we still have to multiply this here, so we get 8x squared minus 6x. We can't combine them. They're not like terms. So we're going to stop there. Moving on to D. D is negative f of x. Well, we know a negative in front just means to put a negative sign there. And then we know what f of x is. F of x is 2x squared minus 3x. That's what they gave us. So we're just going to distribute this negative, or remember it's the same as a negative 1, into that parenthesis. So we have negative 2x squared plus 3x. E is almost the same, but yet now the negative is inside. And so it's more like A and C. So we know we're going to plug negative x in for our x. So we have 2x squared minus 3x. But remember, we're plugging in negative x this time. So because it's square, I'm going to write it out twice. I'm going to go ahead and multiply those parentheses, the squared part, together. So I'll bring down that 2. And negative x times negative x is a positive x squared. I'm going to go ahead and multiply them, and that gives me a plus 3x. And then all I have left is this 2 times x squared, so I get 2x squared plus 3x. Can't combine them. Those are not like terms. All right, then F. F says we're looking for f of x plus 2. So it's a lot like A, C, and E here. So we know we're going to plug x plus 2 in for x. So we have 2x squared minus 3x. So let's plug in our x plus 2. And because it's squared up there, it means we're going to write it twice. So 2 times x plus 2 times x plus 2 minus 3 times x plus 2. Now, this one I can't just multiply all 3 of them in my head like you might have been able to do on some of the others. So I'm going to pick 2 of them. And so I always use the one that was squared. You don't have to. It's just a personal preference. So I'm going to bring this 2 down, and I'm going to have to do FOIL here. So when I do FOIL, I get x times x times 2, 2 times x, and 2 times 2. And then I'm going to bring down the rest of it. Now it's up to you here how you want to do this. I'm going to go ahead and combine these like terms here to make this smaller. So I got 2 times x squared plus 4x plus 4 minus 3 times x plus 2. Now I'm going to have to come back up here and hope I have enough room. So now we're going to distribute. So I'm going to take this 2 and I'm going to multiply it times all 3 of these. And I'm going to take that negative 3 and multiply it times both of those. So when I do that, let's see, we get 2x squared plus 8x plus 8 minus 3x minus 6. And then we're just going to combine like terms. So I have a 2x squared. I have 8x minus 3x, which is 5x. And then we have 8 minus 6, which is a positive 2. And so no other like terms. So there's our solution. All right, and then G, f of x plus h. So we're going to do the same thing we just did. So we're going to take 2, remember it's x squared, minus 3x. And this time we're going to plug in x plus h. Now notice, when I only had on A a number going in, I got a number out answer. On the others, I had an x going in for x on all of them. So I ended up with an x in my answer. So this one I have an x and an h. So I expect to see an x and an h in my answer. Alright, so because of the square, I'm going to write it out. It's 2 times x plus h times x plus h minus 3 times x plus h. I'm going to go ahead and do my FOIL. So I'm going to combine my like terms. I'm going to distribute this 2 and this negative 3. And I'm going to check to see, can I combine anything? I don't have any like terms, so there is our solution. And check out H. H is what they call the difference quotient, okay? And it's using calculus. We're not going to do anything with it except for just simplify it. So we need to know some pieces of it first. Do we know f of x plus h? Yes. We just solved it in G, right? If we didn't, we would have to find it. Do I know f of x? Yes, that's what was given to me up at the top. And then we're just going to subtract them and put it all over h. And this is just notation over here. It says h cannot equal 0, and that's because h is in the denominator of the fraction. Alright, so let's break this into pieces. F of x plus h. We just said that that was equal to 2x squared plus 4xh plus 2h squared minus 3x minus 3h. And we're going to subtract f of x, which f of x at the top was 2x squared minus 3x. And we're going to put this all over h. Now, so the first thing I need to do is try to get rid of these parentheses. So I don't have anything in front of the first one, and then we'll distribute this minus sign, or remember you can see it as a negative 1. So we got 2x squared plus 4xh plus 2h squared minus 3x minus 3h minus 2x squared plus 3x all over h. Now that numerator looks fun, but if you really look at it, you'll notice it's got like terms. So let's go through that. So I see I have a 2x squared that'll cancel. I'm left with a 4xh, a 2h squared, the negative 3x and plus 3x will cancel, and a minus 3h all over h. Now look at your numerator. When you have a difference quotient like this, it is not a coincidence that every term in the numerator has an h in it, okay? So we're going to have to factor that out of all of them. So I'm going to go through and I'm going to take an h out of each one of them. So this one only has one h, so it's going to be gone. The next term there has two h's, so I'm going to take one out, so it leaves one there. The last term only has an h, so it's gone. And the denominator only had an h, so it's gone. And because there's nothing else there, I'm going to put a 1. So we're left with 4x plus 2, there was an h left, minus 3 all over, but do we have to put a 1 on the bottom of a fraction? We don't, because anything over 1 is just itself. And so there is our solution. Whoops, okay. And that's where we stopped on our first day, so that's where I'm going to stop here. In the second video, we'll have the rest of the lesson.